Alright, so let's do an example here. Theorem 9.5, reflections of parallel lines theorem. If lines K and M are parallel, then we do a reflection and then another reflection over these two lines. It's the same as doing a translation. So it's the same as just moving the line around. Alright, so I'm going to throw a diagram up here. You should probably maybe pause the video and copy it down. Alright, let's say I start with line QP here on the left, and I've got K and M are parallel to each other. Right, so they're exactly parallel. And the first thing I do is I'm going to take QP and I'm going to reflect it over K. And then, after that reflection, I'm going to reflect it over M and see where everything ends up. Okay? So that's my plan here. When I reflect it over M, I'm going to end up with P prime here, P prime, and then I'm going to end up with Q prime, which is going to be a little bit further away, right? Q prime up here, and that's going to be my kind of flip. Okay, so I've done one flip, one reflection. Now I want to do another one. So let's do another one. Let's do a different color. Flip it again over line M, right? This is our last flip here. And let me show you what happens. This picture will look something like this. I'm going to take Q double prime now. It's my second kind of move, transformation. And P double prime down here. P double prime. And that's what my line segment's going to look like after I've flipped it twice. Now the important thing to note here is that P prime and P double prime, should be all on one line, and they form a right angle with the two parallel lines. Okay, so that's kind of a special thing that we've got going on here, is that line P double prime, and I'm sorry you guys can't see the this should be P double prime. Can you guys see that? Yeah, okay. P double prime is perpendicular to those parallel lines, which is really important. The other thing that we know is that not only is part 1 here true, P prime is perpendicular to K and M, P double prime is perpendicular to K and M, but also that P double prime equals 2D, where D is the distance between K and M. So if I draw in this distance here from K and M and call that D, P double prime is twice that distance between the two parallel lines. Okay, so we've got two very important things going on. One, this P double prime here, this line is perpendicular to the two parallel lines that we start with, and maybe even more important, P double prime here is equal to 2 times D. So let's see how that would kind of shake out. Part A, suppose P double prime is 62 centimeters, and I want to find the distance between line K and M. Well, remember that this distance between line K and M, right here, I'm actually asking for D. That's what I want. So I'm just going to say that we know this, P double prime equals D. Well, I want D, but I know P double prime. This is kind of part A we're solving here, I guess. We know that P double prime is 62. Equals 2D. Okay, so 2D equals 62. So D divided by 2, D must equal 31. Okay, so D is 31. Cool. If D is 31, let's answer our next question. What is the length of Q double prime? Okay, now this is a little bit different question. I'm looking for Q double prime, so I'm looking for this purple arrow. This purple line segment up here from Q to Q double prime. And you might take a guess at what that is. And I'll help you out here. We also know that this purple line is perpendicular to M also. Okay, which means that the purple line, Q double prime, is the same length as P double prime. So this is something else I know. Q double prime is equal to P double prime, which means that Q double prime is equal to 62 centimeters. They're the same length. Okay. So a couple really important things there to start you off in section 9.5.